Video, I want to show you how to prove that proof from the slides on predicate logic. So let's sort of like take stock here in what we have and what we want to do. So we want to show that there's a cube. I want to show that based on these two premises over here. So the first premise doesn't really say anything about whether something exists. It just sort of simply tells us some sort of like connections, some sort of like property that holds in our domain, and says that everything small is a cube. So all small things are cubes. Then the other one also doesn't really tell us that something exists. It's a conditional, right? It says if there's something that is not a cube, then there's something that is small. Right? So if there's something that is not a cube, then there's something that is small. So really, nowhere do we ever sort of like understand, or is it mentioned that, hey, there's actually something in our domain. It just sort of simply tells us some connections that, that hold in our domain. So how are we going to prove this thing? Well, there's kind of a rule that we can use in this system that we haven't talked about. And so let's talk about that rule a little bit. So what I want to write down is, I want to write down that there's a cube or there's not a cube. So A is a cube or A is not a cube, to be very specific. So notice I don't have any existential quantifiers. I simply use a constant. So I say A is a cube or A is not a cube, to be or not to be, right? So there's a rule over here that talks about tautologies. And so it's the law of excluded middle. In prepositional and predicate logic, we have two truth values, true and false. There are other logics that deal with three truth values, where the third one is unknown, typically. So now notice that immediately you're probably realizing, geez, that logic stuff, I don't know whether we can use it to build information systems, because everything has to be true or false. And in the real world, well, things are not always true or false, right? I mean, there are shades of gray. I mean, they're just we kind of think we know that something is true or not. So how do we capture that? And that's a big research area in logic as well as in AI to deal with these sorts of things. So we have seen IBM Watson the other day, where they use confidence factors, right, into that sort of like capture their belief, or if you wish, that a statement is true or not true. Well, in any case, so this is a rule that we have available, and so let's use it. So we have A is a cube or A is not a cube. All right, so let's get a step afterwards. And so what we're going to do is we're going to do two subproofs. So we're going to use OR elimination. Let's start with cube A, and then eventually we'll want to do something afterwards. And then the other thing that I want to do is a new subproof, not cube A. And maybe end that subproof. So in both cases, what I want to show is that there exists something that is a cube. So let's do that. Actually, I do not need that step here. And let me not delete the entire proof, delete step. So I want to show over here there's an x such that cube x, and over here I want to show there's an x such that cube x. So now look down here, we can justify this one over here through OR elimination. I cite these two and that one, and that step should go through. Sweet. So now, how do we prove these things? Well, this one here, let's do this one first. That is simply existential introduction, right? We know that A is a cube, so we know that there is something that is a cube. So that is this rule over here. We know that P holds of a given of a C that is named, and so we know there's something in the domain of which P is true. So we can just simply use existential introduction, and we cite this one over here and verify the proof. Now down here things are a little bit more tricky, but they will be able to help us. So as you can sort of like see that, geez, we can probably Again, we're going to use this premise over here. We can use this rule, and then we can use this rule to establish that something is a cube. So let's see whether we can do that. So notice that the negation sign is right in front of the cube, and over here, most importantly, the negation sign is in front of the cube, not in front of the external quantifier. That's a really helpful thing to do. So we do the same thing then over here as we did over there. We use existential introduction. So we're going to write there's an x such that not cube x. Whoopsie. And so we're going to do the same thing, introduction of quantifier, and we cite this one over here. So now we can use this rule over here because what we just established over here matches the precondition exactly. So we can write down there's an x such that small x. And so we do elimination of the conditional. We cite this one and this one over here and verify the proof. So now, how do we get from there's something that is small to there's something that is a cube? So we got to use this one over here, but we can't use it outright. So we first have to instantiate this thing to a concrete named entity in our domain. But we don't have any names. Well, we have A over here, but we kind of like need to instantiate that thing. So in order to do that, it is helpful to first remove the existential quantifier over here. So that way we have a name. So that's very important that we do that first, and then we can use that name to also instantiate this universal quantifier. So that's the process that we're going to do. So what we need to do is we need to remove the external quantifier. So let's have a look at that. We have introduction, we have elimination. So if we have something, there's an x such as p of x, then we do a subproof where we give this x a name. It doesn't occur outside, so we haven't used it yet. It has to be a new name. So let's do that. We do a new subproof. And let's call it, I don't think we have used b, and so we call it b, and then we say small b. All right, so now we want to show something. So let's see what we want to show. We have a small b, and so we want to use that b to instantiate this universal quantifier. So what we're going to say is we're going to say small b implies cube b. Okay. And so let's go back to the rule, elimination. So we have a constant that we're going to that we have used somewhere, and so we're going to do that. Elimination of the universal quantifier, like that. So now we want to do, let's see, we have, we want to get QB because we eventually want to establish that there's a cube. So that's not too hard. We're going to write down QB. And we can do that based on modus ponens or the conditional elimination based on the assumption and what we just established over here. So we eliminate, whoopsie, the conditional, and we cite these two steps, and we verify the proof. So now what we're going to do is we want to write down let's go back to the elimination rule. I want to write down what we want to transfer back to our main proof. So we're just going to write down there's an x such as cube x. All right, so now that's going to be transferred back. So let's have a look at the justification of this rule. But before we do that, we want to justify this step over here. So we introduce the external quantifier, and we cite this as a step. And so now down here, we know we're going to have existential elimination. So I'm sorry, introduction. Nope, that was elimination. I was right. So we use existential elimination, and we're going to cite this one over here, as well as this one over here. There we go. So now we have shown that the goal holds given the premises. So there's something that is a cube based on this information. So there are enough constraints over here that we know, yep, there is a cube. All right, very good. I will talk to you later. Bye.